So the big picture for this lesson is segments and circles. So we're talking about chords, secants, tangents. First of all, there's the chord-chord product theorem. Two chords intersect, and the products of each segment are equal to each other. So AE times CE in this case equals BE times DE. Now a secant line is a line that intersects a circle in 2 points, like line GF here. A secant segment is part of the secant line with at least 1 point on a circle. So segment AE in this case can be considered a secant segment. An external secant segment lies in the exterior of the circle with a point on the circle. So segment AD is an external secant segment. Remember, internal means inside, external means outside. Secant-secant product theorem. If you have two secant segments that share the same endpoint outside a circle, then the product of the length of one secant segment and its length of its external segment equals the product of the length of the other secant segment and the length of its external segment. So in other words, for this picture, AB times AC equals AD times AE. And here's an example of using that theorem. You can see you can write an equation, 7 times 7 plus x equals 9 times 9 plus 5. Then there's a secant-tangent product theorem. If you have a tangent segment and a secant segment, and they share an endpoint outside the circle, then the tangent segment squared equals the external secant segment AC times the entire secant segment AD. So AB squared equals AC times AD. So you're just going to use these theorems to write equations and solve for unknown measures, either secant segments or chords or tangents. That's the big picture.